Hello once again, welcome to the second part of our third-person shooter tutorial. Last time we created our camera for our character so that it follows him wherever he goes, and if we click the right click we started zooming in. Now we want to add some more features to it, so the first thing we will do is delete the AI character script we have written in our advanced character controller video, because we don't gonna need this right now, and in later videos we will see how to write the AI for our enemies from the start. So open your character movement script. Okay, open it, and now the first things we want to add is some our variables which we're gonna use. The first variable we will need is, we will call it auto turn threshold. We'll give it a value of 10. Second is our auto turn speed, give it a value of 20, a boolean that it's gonna help us to determine when we are aiming, and a vector 3 which is we will call it our current look position. And now we're going to write a new function. Let's go down, which we will call turn towards camera forward. So now we want this function to make our character turn where the forward of the camera is. So the way we do this is we will start with an if statement, and we will say if the absolute value of our forward mount is lower than the value of 0.01f, then we want our look direction, which is a new vector 3 we will call look delta, equals transform dot inverse transform direction our current look position minus our transform dot position. Transform dot inverse transform direction simply transforms a direction from world space to local space. Now we want this to be in angles, and the way we do this, we add a new float which we'll call look angle, and we will call mathf attenuation 2, which returns the angle in radians, and we will say we want our look delta x and our look delta z, and now this we will be multiplying it with mathf dot rad 2 degrees. Now this makes radians to degrees conversion. And finally for this we will say if the absolute value of our look angle is higher than our auto turn threshold, the turn amount is our look angle multiplied by our auto turn speed multiplied by a value of 0.001. So now that we have our function, let's go and make changes to our movement function, to our move function. Now we will start by adding some variables here. We will say first we will need a bool which we'll call aim, and a vector3 which is our look position. And now we will add, under our convert move input function, we will add the new function. And then we will start by assigning the function movements to the function variables, to the variables inside the script. So we will say this dot aim equals aim, and this dot current look position equals look position. This is simply because we want to be accessing these variables, and this is how we connect this from another script. That's it for the moment, for this script, but we will return later. So of course, if we save here, we will start getting errors because our user input script we call our move function from our user input script, but we haven't assigned the variables we need. So let's go fix this. The first thing we will add, let me delete this stuff, we don't need this. So the first thing is we'll add a boolean which we'll call look in camera direction, and close it, and a vector3 look position. And then we will go to our fixed update, to our where we call the move function from our character movement script, and we will say the move vector3 is of course what we have done from on the previous videos. The aim will be the aim, and the look position will be the look position. Now we want to start calculating the look position, because right now it will always return 0, 0, 0. And the way we do this, we will go over here and we will say our look position equals if look camera direction is true and we have a camera, then it will be our transform dot position plus our camera forward, something I'm missing, transform dot position camera forward multiplied by 100, else transform dot position plus transform dot forward multiplied by 100. Now, as you remember this from the previous video, this statement right here is exactly the same, like saying if look in camera direction and camera is not equals null, do stuff, else do other stuff. This is exactly the same like this. Okay, but since we can write it in a more compact way, we write it like this. Now let's see what we have done. Save it, let's go back, let's see, we don't have any errors, hit play. As you can see, it doesn't play. Now let me see why not. Yeah, it doesn't play because of course we haven't make it through our boolean, our look in camera direction boolean. Now if we hit play, as we move the camera, it moves the player with it. Now of course we have to decide how we want our player movement to be. Games like Grand Theft Auto, the player only turns when to face the camera when there is some input, or when there is when the player is aiming. Now, but games usually from companies like Ubisoft, if you play the thing, it's Ghost Recon, I don't remember. Anyway, the player always faces where the camera is looking. So let's make it more like GTA, because we can do more stuff with it, stuff like that. So in order to do this, let's go back to a character movement script, and we will say if we are not aiming, we will say, actually we only want this, yeah, we will say if we are not aiming, do not apply extra turn rotation and turn towards camera forward. And I think, yeah, the next thing we want to add is of course make a boolean for our animator, which is just called aim here, to be the same as our aim. Of course we haven't set up the animator right now, so let's comment this out and we'll return later for this. Okay, so now we will go back and say, we will go back to our user input script and we will say if we are not aiming, and put all the code behind inside the if statement, and else. Yeah, so we go back to our user input script. in our fixed update, and we will say if we are not aiming, do whatever you were doing all this time. But if we are aiming, we will zero in our move vector. We want to start giving we don't want him to have any movement, and we will say we will add a new vector 3 which we will call dir from direction. We will say our look position minus our transform dot position. We will make our dir y, the y of our direction, to be at 0, and we will say our transform dot rotation equals quaternion dot slurp transform dot rotation quaternion dot look rotation there, and we give him a greater value at 20 by time dot delta time. Now what we're doing here, we're basically saying to our script, to our character, that if we are aiming, do not have any movement at all, and start looking where our look position is. So rotate our character where we want him to rotate. Now of course I think we have missed something. Yeah, now let's see what this will do, and we will say, as you see here, when we're done aim, it's exactly the same like before, and when we aim, our character rotates. Now this jerkiness is from mostly from bad animation, so don't care about this right now. We rotate, and if we hit WASD, our character doesn't move. We do this because we don't want him to use the previous way we control him when we are aiming, because we want to previously, or right now, if we hit A, you see the character goes to the left, D goes to the right, and this is based on how our camera is facing. So if we hit forward, it will always go towards the camera. But if we are aiming, we don't want him to, when we hit A, we want him to move to the left in a strafe position. We don't want him to rotate to look at the left to do this. So we override their controls, and now we want to make our new animator so that we can move him to the left and to the right. Now below you will find a download link with some animations which are based off from the we won't need this, which are based off from the animations Unity already gives you. Let me clean this up. And inside the part 2 folder you will find, no, you will not find, yeah, I have it on another folder. So anyway, let's go to our animator. Let's create a new blend tree. Let's call it pistol aim, or simply aim. Anyway, we will add a new boolean, and we would simply call aim. We make end transition from are grounded to our aim, and we will say when the aim is true, transist to the other blend tree, and when it's false, transist back. Now open up a blend tree, we'll make it again VD freeform Cartesian, and the parameters will be forward and turn. Once again, we will add 4 motion fields and go to our humanoid sneak. I have already fixed the animations here from the stuff Unity already gives you. As you can see, we have a walking forward, a walk left, a walk right, and a walk backwards. We also have a turn right, but it's not so good, so it's best we don't use it. So anyway, let's go back to our script. We have added, actually we want 5 motion fields, and as we did before, we drop the idle, the walk forward, walk backwards, walk left, walk right. Now of course the idle we want to be at 0, 0. The walk forward we want it to be at, actually we're going to give him a 0.5 value on the walk forward. On walk backwards we want to be at -0.5. At walk left the x will be at 0, and pause on the y we want him to have a -0.5, and to walk right 0.5. Okay, it's the same, it's almost the same like the previous blend tree we had, only this time we have all the values, and because these animations are a little bit slow, we're gonna up the speed to 1.5 from 1, so our character move a little more faster. Now of course these animations we're working with the stuff we already have. Okay, so if you have better animations, it's better to use those stuff. I use this because we can share it, because it's free and Unity already gives you. So now that we have set up for now our animator, let's go back to our user input script, and on our fixed update where we say if we are aiming, do not move from our character movement script, and actually we want to override this, the character movement script, so we will want to call our animator from here, and the way we do this of course is add a variable of animator to the top. On start, assign the reference, okay, so now we can access the animator from here. So we go back and we will say if we are not aiming, remember, if we are not aiming, do the stuff you're already doing. If we are aiming though, we will say our anim set float forward is the same with our vertical float, and our anim set float turn is the same with our horizontal. Now of course we call the we could have just pass the values from to the other script, but since we have already set up the system and it's working pretty nice, we don't want to mess this stuff, so let's just do this from here. And let's go back, see what we have until now. So we are moving the way we're supposed to do, and if we hit aim, yes, of course, we haven't added the we forgot to turn to uncomment the boolean from our character movement script. Okay, so as you see here, when we're aiming and we hit left or right, our character moves different, and if we hit forward, it goes forward. If we hit backwards, it goes backwards, left, straight, right. Now of course it has a little minor problem there, but it's okay for now. As you can see here, that's a weight problem. Somebody was careless over here. I fold some stuff. So this is a vertex that is that somebody haven't assigned the weight, so it's tracing out like this. Of course, in your character you'll be more careful for that. So now we have all this. Now let's go make our character to look. No, but before that, let's go and start make our character aim. The first thing we will of course need is a weapon. We have a model from the package you downloaded, import it, and the way you load the weapon is go to his right hand, drop the gun, fix it to have the correct position, of course it's a little smaller. It might be good. I think it's a little smaller, so let's scale it a little more. Doesn't matter, you can do however you like it. So let's keep it like this for now, but let's go and add an empty game object inside this. We will add it later. We'll just call it bullet spawn point, and move it to the top of the gun, to the front. We will see later how we're gonna use this. So let's close that. Let's go back to our animator. Now let's add a new layer. We add the weight to 1. Let's call this right hand. And create an empty state. We will start making we will start adding animations for our movement, for our holding, for holding the gun and stuff like that. Now inside your folder you will see a basic snake model. Say there, inside there are some animations I made. Okay, there is two pistol idle animations. Use whichever one you prefer for this, and I'm going to use the pistol idle. We will make a transition from the empty state to our pistol idle, and we will say if the aim is false, then move to the pistol idle position, and if the aim is true, you can return to the empty state. And we will assign an avatar mask. There is already inside the folder. So if you click the cycle over here, it will show you which avatar masks are available. Now this avatar mask simply has one arm select. Now this is when our character is not aiming. Okay, so we don't have to make a new animation with him walking around just holding the hand, the weapon. We simply blend between animations and on top of the others. We simply, with the avatar mask, we say override the animation of the right hand and play them all together. Now of course we want to another layer to our animator, which will call upper body. The weight of course will be at 1, and we will assign the upper body avatar mask. We need another empty state, which we will call empty, and simply here we will throw, drag and drop our aim animation, and we will say if aim is true, transit to that animation. If aim is false, transits back. Now we will see if we are aiming. We start aiming. Now of course, as you see, the orientation of the player changes a little bit when we are moving, and of course the hand is not in the correct place. That is because the animation was made on a different rig than this character, and that rig was from the default avatar of Unity. So sometimes Mechanim has a little offset. The way you can fix this is by going to masks and changing the restrictions, but we won't do it this way. Let me just scale this, doesn't look that ugly. We won't do it this way because later on we will probably see how to make an IK system, so we can fix the hand positions from there. Okay, so let's revisit what we have so far. We will hit aim, we are aiming. We have left and right, back, we are moving. Now of course we can add to the animator, we can add a new parameter trigger, and we will say fire, and drop the animation here, and we will say if there is trigger fire the gun and return when you normally will. nope, not here, that's the wrong. We want him to be on the last layer. I added by accident on the first layer, so let's do that again, and we will say if we are aiming and there is the fire trigger, play the fire animation and then return back to aiming. Of course we haven't set it up the fire, so we will just leave it for now. And now the next thing we will do is, if you look closely here, you see that our character is not exactly looking where in the center of the camera, and if we move the camera down and up, our character keeps looking always at the same position. Now the way we can fix this is we will create something like an inverse kinematic solution. It's not exactly an inverse kinematic solution, but it's pretty good, so we can use it. Now of course this is a little more advanced, so pay more attention here. Now we will first need a reference to the spine of our character, and then we will need some floats that they will help us have the character look at the correct position. We make these floats public so we can access them and really set them correctly from the inspector, so we don't have to move back and forth from script and from the game. Now of course these values I've tested them, and I will show you in a minute how you can find your own values, but the problem with this is that depending on its rig, you might need to change these values accordingly. So these values, if you have a different character than the Ethan character Unity gives you, there's a good chance these values won't make your character look correctly. Okay, so you will if you use a different character and a different rig, you will have to find this stuff again. And now we have set this up. Let's go back to our late update. We do this in late update because we will be overriding the animation. If you do this in update, we will have our character will have a lot of jerking motion. So we do this after the animation play. We say override the position and look at where we want to look, and we will say if the aim is true, we will need a vector 3 we will call Euler angle offset. Vector 3, we will start by having this at 0. We will say our Euler angle offset is equals a new vector 3, which will say the x will be the aiming x, the aiming y will be the aiming y, and the aiming z will be the aiming z. And then we will say we will add array, and we will start it from, we want to make array from the forward of the camera, starting from our camera position to our camera forward. Okay, this simply makes array where a camera is straight forward where the camera is looking. And then we will say our look position is equals ray get point r point. This is not so simple stuff, so let's go back again. We will say if we are aiming, this will have the character's spine, have the rotation we want, and this will make the character look, the spine of the character look in a point forward from the camera at the value we give him. So here we have the value of 30, so the character will be looking 30 points in forward of the camera. And now we have all this. Of course, we want to make our character's spine to look at the position, and we want to rotate our camera on our ruler angle offsets and on space self, on the space is relative to self. So let's go and see what we did. Of course, save before you, let's save in here actually. Hit play. As you can see, the character is how it was before, and if we hit to start aiming, now something's wrong here. Oh yeah, and I think I know what it is. Let me just there was somewhere, yeah. So let's take this where we turn the aim, and we will say in update, we will put it in update, the point where we make the aim boolean to true. If we click the right button and put it in update, so it happens before the late update. Let's go back, let's hit play, and still does play. Oh yeah, of course, we haven't set up we haven't dropped the spine. So take the spine, the way you find the spine or which bone you want to turn. What? Now there's a little problem over here from what I see. For some reason the Unity has stuck to the gun. Anyway, so if you see here, oh yeah, we have it on the center. If you see here, we see how the character we want him to look, to rotate. Now this bone seems correct. Of course, if the character wasn't made for stuff like this, you will have some stretching problems, as you see here, that seem unnatural, and stuff like this. You see that it's going out of its place. Of course, your character will be made for this kind of game, so you won't have problems like this. So let's go back to our scripts. Let's drop the spine 1 from the character. Let's hit play, and as you can see, now we can aim. We hit up. Let's go back into our camera. Let's make our turn speed from the camera something like 5, so we can turn faster. Now that's a little too fast, as you can see. Now there is some jerkiness, and that's mostly because of the animations. It's not the perfect solution, so don't care about that. Now if you see here, of course, you see the character is a little bit seems like floating, but if you notice, in most games, GTA 4 for example, if you look down the camera, you will see him floating, but the way they do it there is have the player pretty close to the camera, so most times nobody will notice. The enemies don't move the same way like we do, so usually you never notice it. The only place you might notice might be on multiplayer match, but this of course happens in even games like GTA 5 and even the most newest next gen games, so it's not our biggest problem. And if you see here, if we are looking at the different direction and we hit aim, our character automatically turns to where the camera is looking. So how you can find the correct angles for your own character? Okay, this is very important, because it's probably the same rigs can never be the same. Only if you use the same rig to skin your character, and you have a universal rig, only then you won't have these problems. But since most programmers don't even have an animator, it's nice to see how you can fix this. Even if you don't have the correct animations, it's nice to see how you can fix this on your own. Now we will go back to our user input script for now, and we want to comment the aim just for now, and we will click the boolean for aim here. We will stop the maximize. We don't want him to maximize when we hit play, so we can change the values. And if we hit play, you can see our character is aiming without us holding the right button. Now let's click somewhere else so our character stops following the mouse. And now we are free to change the values, our floats, to make it look at the correct place. Okay, so that's the way you can do this without having guessing the values. Now what you will do, you want him to do is look towards the center of the camera. And that's how you do it. After you've done with it, just simply click the gear button to the right, click copy component, and then after play, click paste component values. Now I have already found the correct value, so I won't do it here. The next thing you can do, of course, is change the pivot of the camera. Make it look more realistically, or how you want it. Of course, we have left the user input over here, so let's uncomment that. Now we are near 50 minutes. We are near an hour, so let's see what else we can do. So what we have so far, we made in this video to play a different animation where we are aiming. We are overriding the movement of the character. We made something like an IK solution. It's not exactly an inverse kinematic solution, but it's a term you will find a lot, even if this is not exactly the inverse kinematic solution. And we can aim now. You can see. Now, of course, we want to make, if we hit the right button, to start shooting. Now let's go quickly back to our user input, and we will say if aim. Let's go to update, and we'll say if we are aiming, and if we click the left button, then we will say we will trigger the trigger parameter from an animator to play the correct animation. Let's hit play, and if you see here, if we hit the click, we play the animation that is the shooting animation of our pistol. Okay, now of course we want something to shoot. Now there are many ways to make bullets. The most common is with instantiation, but because there are many tutorials on how to make those, let's see a different way. I have inside the folders, you will find a particle, which is the particle of the bullet. So drop it inside the scene. It doesn't matter to be inside the third person character, because we will be overriding the position and the rotation of this, because we are using a lot in late update. We are overriding the orientation of our character. The particles do not emit on late update, so we won't have any precision. But the way we can do this, so if we drop the particle inside the pistol, our character will be aiming up, but the particles will almost always be going to another direction. So drop it inside the hierarchy, and let's see what we can make, how we can fix this. Let's create a new script. Actually, we're gonna go to our script and create it. Create a new script, and we will say particle direction script. Open it up. Now we only want a transform, we can simply call it weapon, and we won't need the start, and we will say transform.position equals the weapon transform point vector3.0. Now we are saying that this particle system, this particle game object, has the position, the world position, the weapon has in the world position. Okay, the weapon is inside the character, so it will always have a local position, but with transform.point, with .transform point, we convert the local position to a world position. And of course we want to say to have them both face at the same direction, and the way we do this is by saying transform.forward weapon.transform direction vector3.forward. So this does the same thing, only for the direction. So it transforms the direction of the weapon from local position to a world position. And if we go back and throw the script inside our particle, over here, and we will give him not a weapon but the bullet spawn point we created, the empty game object we created inside our weapon. And now we want, on our user input, we want to have a reference from our particle, for our particle, and the way we do this is by adding a particle system which we call part syst. We will make it a public for now, and we will say in update if input get mouse button 0, which means if we hit the left mouse button, then particle system emit, we will say 1. If we put 5, it will emit 5 bullets or 4. So in this way we can simply, in a more easier way than instantiating a prefab and arranging random values, if we have something like a shotgun or a rifle, this is the same. Like, instead of doing all this, with just adding a few stuff, you can have the same result. And if we go back now, and if we hit play, let me maximize that. If we hit play, it doesn't shoot. Let me see why it doesn't play. Yeah, because we haven't assigned the particle system. Drag and drop it to our user input script. Let's hit play. Now of course does something like this. Now let's see why this happens. And wait a second. Yeah, because we have the particle system to emit when we are aiming. and we want him to only emit when we hit the left click. Hit play once again. Emit. Now of course it has the wrong direction, and that is because our bullet spawn point the forward of our bullet spawn point, as you can see, is up. We want this, blue to be facing not like this, like this, to be facing to the point where the bullet is going to fly. So we hit play once again. As you can see, now there are, as you can see, if we hit collision. Now of course we can restrict this stuff from our particle emitter. So let's go here. Now particles already have there is also collision awareness inside particles. So if you enable collisions and send collision messages, then you can go to the previous script. We have particle direction and we can simply say void. We will call a mono behavior function which is called on particle collision game object other, and we will say if other dot game object dot rigid body we want to find the direction, which is other transform dot position minus our own position, and the direction we want to be normalized so we don't have to mess with high values, and we will say to the rigid body we've just hit add force direction multiplied by 50. Now let's go back to our game. Let's create some objects to start shooting. Let's make it a little smaller. Add a rigid body here. Let's hit play. As you can see, it's almost exactly the same, like having instantiating a bullet and throwing it and changing the add force, stuff like that. So I think that's about it for now. Of course you can inside the part there is a gunshot. You can put that to play when we are hitting. The way you can do this is of course by adding an audio source. Drop the gunshot here, and we will say, we'll go back to your user input script, and we will say, now I'm doing this the lazy way. We can quickly go and get a component either which is of the audio source, and we hit play one shot. let's make sure this doesn't play on awake. No, yeah. Instead of play one shot, we just hit play one shot. It needs an audio clip to hit, and play just plays whatever you have assigned it from there. As you can see now, it doesn't play. Damn it. Now let's see why it doesn't play. Oh, you know, it plays, but I have the volume down, so we don't get echo on the mic. So that's about it for now. Of course, you can assign in the renderer. You can change stuff like this. You can add material, the material you want to add to. Let's just drop something to your particle anyway. Let's do this. You can even add a mesh. So if you want bullets like the ones in Max Payne, where it was actually a mesh, a bullet, and you want to zoom in on the bullets, you can do it from here. You can change a lot of stuff. You can change the size. You can change the shape. You can change the speed, as you can see from here. You can even change the shape. And if you put a higher angle like this, hope you can see it from the video. And you want him to emit, let's say, 6 bullets. As you can see, you can create almost every type of weapon from this, or not almost, all weapons from this. And if you have a great angle like this, you can even add bursts. And as you can see here, you don't have to make random directions if you are making a shotgun. The way you will do this in instantiation, you will have to make a random algorithm that makes the bullets fly like this. You can even enable bounce or disable it from the particle system. Okay, you can do a lot of stuff, the easy way. So that's about it for this video. We are running near an hour and even more. There was a lot, we did a lot of stuff here. If you have any questions or something doesn't work, prefer to use the subreddit. It's the fastest way I will see it. If you have any questions, suggestions or everything else, we will see what we will make in the next video. We might continue making this. We might see how we can make an IK functions. We might see how we can make we can write our own AI for our enemies. We can do a lot of stuff. Okay, so if you have any questions, if something doesn't work, go again from rewatch the video. There was a lot of pretty advanced stuff in this tutorial, so it's completely understandable if you didn't understand something. So let's go see it once again, what we did in this video. We added our variables here in our character movement script. We added, of course, first our variables we will need. We created a new function that it's going to make our character turn towards where the camera is looking. We updated our move function here with our turn towards camera forward. We will say we want him to, if we are not aiming to turn towards camera forward, this actually might not even play right now, might not even need it over here, but you will need it, you will have to add it somewhere, but it depends. Anyway, we don't want him to apply extra turn rotation because the character will move a lot fast. Don't forget to assign the variables we are passing from the other script to our internal variables here. And on our user input, we created a reference to the animator, so we can override the animator, the reference to our particle system, so we can shoot bullets, the angles for the IK, the stuff we will need for the IK in quotes, set up the reference to the animator, create the update function. Inside the update put the if we are aiming, and if we are aiming, if we hit the mouse button, the left mouse button, shoot, play the shoot animation, the fire animation, shoot the bullet, and play the sound. Now on late update, we created the IK. So if you aim here, create the new angles we want the spine to have, create a ray from the camera to where the camera is currently looking, and the look position of our character is the point we have set up in the beginning to be, and then make the spine, the bone of our character, look at that direction and give him the correct values. And on fixed update, we put our previous stuff inside the aim. If we are not aiming, the previous stuff we are already doing, but if we are aiming, we want to zero the movement so it doesn't move from there, and create a new look position, so where the player is always looking towards the forward of the camera, the rotation anyway, and override the animations so it will play the left and right without having to mess with our previous functions. And of course the look position is if we have the boolean true to our camera look direction, we have a camera, it's the transfer position relative to the forward of the camera multiplied by 100. If there is not a camera, it's the transfer position and the transfer position dot forward multiplied by 100. We pass to our to the updated character move script, to our updated move function, the move, the aim boolean, and the look position. Okay, and we have this simple script for our particles, where we shoot our bullets, and we will say public transform the weapon, have the position of the weapon in the wall space, and the forward direction of and have the same direction basically where the weapon has. And on particle collision, if there is a rigid body in the object we hit, add force to it based on the direction, and the force you can put whatever you like. Over here you will say if other dot collider dot tag equals enemy, and you will start subtracting from his health, stuff like this. The next thing we do in this video is of course set up the animator over here. Okay, so that's about it. This was longer than the previous ones, but we cover a lot of stuff, pretty advanced stuff. Go back at it and watch it again if you don't understand something. If you still can't figure it out, message me or use any other platforms you can communicate. So thanks for watching, and we will see you in the next week.